Okay, welcome everybody to the MGF 1107 Test 1 Review Workshop hosted by the Learning Commons. I'm Noah Schmidt. I'm a math specialist in the Learning Commons, and I'll be facilitating the workshop. And so there's about 17 problems that we're going to go over that are based on concepts that you would have learned in Unit 1 for MGF 1107. The way this is going to work is I'm going to give you, it'll vary how much time I give you on each problem before we go over them. But I like to give, we have about an hour and a half allotted time. So I like to give you a little bit of time to try at least attempt the problem on your own first. And then we go over them together, and then I just see if there's any questions. If you could go ahead and put your name into the chat, that would be great. That way we have a record of your attendance, and then we'll go ahead and get started. Thank you, everybody that's putting your names in the chat. So let's start going over the problems. I'm going to read the problem and then give you time to go over it first. So this problem is basically based on the pairwise comparison method. This says 43 voters are asked to vote on the theme of this year's homecoming festivities. The 1950s is F, the 1970s is S, or the 1980s is E. The votes are summarized in the preference table, and we're going to determine the winner by the pairwise comparison method. So I'm going to give you about, let me give you about 2 minutes on this problem to try it on your own to see if you can determine the winner by the pairwise comparison method, and then we'll go over it together. Thank you. Now, on the pairwise comparison method, the first thing to do is to determine who the candidates are. So we've got E, F, and S. So we need to keep in the pairwise comparison method, we need to keep a score, a running tally of the scores for each candidate. So E, F, and S. You can feel free to ignore the vertical line here that just popped up. Sometimes that happens on this drawing pad, and so we're going to keep a little running tally of the points. Then you have to determine how many, because what you're going to do is compare each candidate head-to-head, and you have to determine how many comparisons to make. Now with there's a formula for it, and the formula is that it's n times n minus 1 all over 2. That's how many comparisons we need to make. Now n is the number of candidates. In this particular problem, there's 3 candidates in the election. So this is going to be 3 for your n times 3 minus 1, which is 2. So all over 2, and 3 times 2 over 2 is 3. So we need to make 3 comparisons on this particular in this particular election. So we're just going to make 3 tables for our comparisons. And who are we comparing? Well, we're comparing each candidate head-to-head with all the other candidates. So we'll start out by comparing E with F. Then we have to compare E with S. And then we got to compare F with S. Now, the way to determine who wins each head-to-head matchup is to calculate how many voters prefer one candidate over the other. For example, if we're comparing E and F, if we look at these 19 votes here, well, they all preferred E over F, so E gets those 19 votes. Go to the next column, 10. Well, these 10 compare F to E. Go to the next column, these 10 compare F to E. Go to the next column, these 2 compare F to E. Go to the next column, these compare E over F. And then the last column, that one voter prefers E over F. Now, if you look at this and you calculate the total of the points, F wins because F has 21 points and F has 22 points and E has 21 points. So what happens is if whichever candidate wins the head-to-head matchup gets a point. So comparing E to F, E gets a point. So we're going to put a tally mark in E's row.
Do you mean F wins?
Or yeah, F, sorry about that. Yeah, you're right. Misspoke. We go to the next matchup now. Okay, now I'm going to get you guys involved a little bit. We're comparing E with S, so who do these 19 voters prefer?
E.
E. All right, what about these 10?
E.
E, yep. And these 10?
S.
S. These 2?
S.
S. This one?
S.
S. This one?
E.
E. So E's going to win this one. E got 30 votes, or 30 total votes, and S got 13. So E won that one. So E gets a point on that one. Now we're comparing F with S. Well, if we're comparing F with S, then these 19 prefer F. These 10 prefer F. These 10 prefer S. These 2 prefer F. This one prefers S. And this one prefers S. So again, this is going to be 31 to 12 on this one. Got something in the chat here. Yeah, because basically F just won this head-to-head matchup with S. And so now F gets another point. And now when you compare, once you've done all the head-to-head matchups, then whoever has the most points in the running tally wins. So F wins the pairwise comparison method there. All right.
I have a question.
Yes.
For the pairwise comparison method, do we have to use it? Because I mean, obviously you can see there's three choices. So, you compare three choices. So do we have to use the pairwise comparison method?
Well, if it specifies that that's the method to use, because there's 4 methods that you learned. You learned the plurality method, the plurality with elimination method, the pairwise comparison method, and the board account method. So there's different ways of determining who wins an election. So pairwise comparison is just one method.
Okay, got it.
All right, and we're going to go over one of each kind in this each kind of method for voting in this review. So, any other questions? Okay, the next.
Oh, I'm sorry. Are we going to be going over the criterion too?
Not necessarily all of them, but we'll go over quite a few of them. Yeah.
Okay.
It's kind of a practice test that this is
PowerPoint.
Yeah, right? So it doesn't necessarily. It just sort of picks, problems from the unit to make a practice test, and so I designed this based on that. So.
Okay.
But this problem says a reality show is considering 3 cities. This is the head-to-head criterion. So a reality show is considering 3 cities for their new season. Paris, which is P, Reno, which is R, Dallas, which is D. The preference table for the election is shown below. Reno was favored over all of the other cities. However, the winner will be determined by the plurality method. The votes are summarized in the preference table. So basically, in head-to-head, Reno, or in the head-to-head criteria, head-to-head with other candidates, Reno was favored. So what the head-to-head criterion states is that if Reno was favored, wins head-to-head over all the other candidates, then Reno should win any method that you have an election on. So Reno basically won head-to-head over all the other cities. Now they didn't show us that, they just gave that. That's given information. It says right here, Reno was favored over all the other cities. So what they're saying there is Reno wins head-to-head against all the other cities. So you can take that as given information. Now, if for the head-to-head criterion to be satisfied, Reno should win by any other method. And so the winner is going to be determined by the plurality method. So Reno should win that. If Reno doesn't win that, then the head-to-head criterion is not satisfied. So let me give you about a minute. The plurality method's not as long to do as a lot of other methods. I'm going to give you about a minute to try to determine who wins by the plurality method and whether the head-to-head criterion is satisfied. So let me give you a little bit of time and then we'll go over it. I'll give you about a minute. Thank you for letting me know. That's for the person that just put that in the chat. so let's go ahead and go over this. The plurality method is basically the way to determine who wins by the plurality method. That's just whoever got the most first place votes wins by plurality. So if you look at this, it looks like, so who did you guys get that wins the election off of who gets the most first place votes?
Paris.
Paris won, exactly, because Paris got 7 first place votes and the other candidates didn't get that many. But Reno won head to head against all the other cities. So Paris won the plurality. Reno won the head to head against all the other cities. So is the head to head criterion satisfied?
No.
No. And the reason is because Reno did not win the election by the plurality method, although Reno did win the head-to-head method, head-to-head against all the other candidates. So, all right, anybody have any questions on that one? Okay. The next one is Jefferson's method. Let me read through this problem. This says the science department has 30 teaching assistants to be divided among 3 courses according to their respective enrollments, shown in the following table. Use Jefferson's method with a modified divisor of D equals 550 to apportion the teaching assistants. How many teaching assistants will earth science receive? So the question is on Jefferson's method, which way to round. So let me let you try this for about a minute. You just have to figure out how many teaching assistants earth science will get based on a modified divisor of 550. And so let me see if you can determine that. Well, what you do to determine, you have to get the modified quota to determine how many teaching assistants each department will get. And we're only interested in what the earth science receives or will receive based on the information given. So modified quota is what we're looking for. Now, what you do is you take the total enrollment for earth science, which is 5,500, and you divide it by the modified divisor, which is 550. Now, let me ask you guys and test your understanding from how much you remember from class. How do you round on Jefferson's method? Up, down, or normal?
Down.
Down, that's right. Now, it doesn't really matter on this problem because what was Jefferson's modified quota? 10. So there was no rounding that was necessary on this, but rounding down just means chop off the decimal and you've rounded down. And it just means you go down no matter what. So if you had 10.4, you'd have 10 if you rounded down. So that's what Jefferson's method does after you get the modified quota. So 10 teaching assistants go to earth science. So does anybody have any questions on this problem? All right, let's try the plurality method. This is another problem with the plurality method. I'm going to give you guys a chance to do this one for about a minute. So it says 43 voters are asked to vote on the theme of this year's homecoming festivities. You got 1950s, which is F, 1970s, which is S, or the 1980s, which is E. The votes are summarized in the preference table, which theme is selected using the plurality method. Now, we've already had this preference table on problem 1. But the problem 1, we were determining the winner of the election based on the pairwise comparison method. This problem, we're determining it based on plurality method. So plurality, again, is who gets the most first place votes. So let me give you about a minute to try that on your own, and then we'll go over it together.
I'm sorry, I had a question about the last problem.
Yes, sure.
Because 10 was a whole number, is that the reason why it was because the other ones, the other numbers like 7,500 and 4,000 came out to like a decimal?
Right.
But like would it be because it's a whole number?
Right. If it's a whole number, then you don't necessarily need to round at all.
Okay. I got it.
You just go with what you got. Yeah.
Okay.
All right. Thank you. Well, on this problem, so who got the most first place votes on this problem?
E.
E, because E got 20. F got 13, it looks like. And S got 11. So E won that one. Okay. All right. Does anybody have any questions? All right. All right. This is a standard divisor problem. We'll just do this one together since there's really just one step to it. This says 14 teaching assistants are to be assigned to courses based on their enrollments. Find the standard divisor if the combined enrollment of the courses is 15,000, round to the nearest hundredth. So the standard divisor is basically the total population of whatever you're allotting, whatever you're pulling from as your population, divided by the total number of items to be apportioned. And so we just have to do that on this problem. On this problem, we've got 15,000 divided by 14. These vertical lines sometimes pop up when I'm writing on this drawing pad, but so what do you get when you divide 15,000 by 14? I got 1,071.429, but we want to round to the nearest hundredth. So the nearest hundredth is 2 decimal places. So you look to the right of the decimal, 4 is in the 10th place, 2 is in the 100th place, and then you look to the right of the 2, and that's a 9, so 5 or more rounds the 2 up to a 3. So this is going to be 1,071.43 would be our standard divisor rounded to the nearest hundredth. So there's a formula for this standard divisor. All right, does anybody have any questions? Okay. This is the irrelevant alternatives criterion. Now this is just going to be I'm going to test your understanding here, but there's not going to be any math steps on this problem other than just knowing what the criterion says. This says 4 candidates in a race for an election, or in a race for election. You got candidates A, B, C, and D. Candidate B won over all the other candidates by the pairwise comparison method. Suppose that candidate A drops out of the race. Candidate B still wins by the pairwise comparison method. Is the irrelevant alternatives criterion satisfied? What does everybody think?
Yes. It's been satisfied.
It has, because what happens is if you have a certain number of candidates and one candidate wins, and then the only changes in a re-election are that one of the candidates drops out, one or more candidates drops out, then it says that the candidate that won the original election should still win. And if the same candidate wins after one or more candidates drop out, then it's satisfied. So this one's going to be yes. All right. Does anybody have any questions on that one? All right. Here's Webster's method. Now here's another one that doesn't require any work, but this is more just understanding how Webster's method works. Suppose that the modified divisor that Webster chose did not work. So what that means is you're apportioning items, and what you would prefer is when you choose your modified divisor, and then you take your population of each group and divide by the modified divisor and start apportioning your items, you should get the same number of items that are being apportioned. So what ends up happening here is there were 25 seats to apportion, but his first try gave him only 22 seats apportioned. So what would he need to do with his modified divisor? What would be his next step? Would he want to lower his divisor or raise his divisor?
Raise.
You actually want to lower it. Let me give you an example here. Lower, or let me just write the rule. Lower divisor equals more items to be apportioned. I'll show you why. Higher divisor, it's the opposite of what you might assume, equals less items. Let's just take 1,000 as our population of a certain group and divide it by 50. Well, how many items would that be? Well, if you took 1,000 and divided by 50, you'd have 20. 50 is the example of the modified divisor on that. I just made that up as an example, but what if we took 1,000 and then took our modified divisor and lowered it from 50 to 40? Now all of a sudden this 1,000 divided by 40 is now 25. So what that represents is when we had a modified divisor of 50, we are apportioning 20 items. And if we divide by our modified divisor of 40, which is lower than 50, then we are allotting 25 items. And what you're trying to do here is you want to allot more items. On the first try, he only had 22 seats apportioned, and he needs to apportion 25, so he needs more seats going out. And the way to do that is to lower your modified divisor. And it's trial and error when you're choosing these divisors, basically. Webster's method is rounding normally, so that's what ends up happening on Webster's method. Is it's just you have to know which way to go when you're choosing a modified divisor, or then you have to, if it doesn't work, you got to know whether to lower your divisor or raise your divisor. So does anybody have any questions? Okay, let's try this problem. With 9 candidates in an election where the pairwise comparison method is used, how many head-to-head pairs will there be? Does everybody remember the formula that I listed on problem 1? Anybody remember it?
Is it C equals N parentheses N minus 1 over 2?
That's right. It's N times N minus 1 over 2. So let me give you about a minute to try that on your own. So you have 9 candidates, and we want to determine how many head-to-head pairs there will be. So I'll give you about a minute on that one. All right, so we want to substitute 9 in for N. And so we'll go ahead and do that. So 9 goes where N is. This is 9 times 9 minus 1 over 2. But this ends up being 9 times 9 minus 1 is 8 over 2, which ends up being 72 over 2, which is 36. So if you had 9 candidates and you were determining the winner by pairwise comparison, you'd have to make 36 comparisons to determine the winner. So does anybody have any questions on this problem? All right, we've got Hamilton's method on this one. So this one we'll go ahead and do together. This says a small country is apportioning seats among its 5 states based on their respective populations. State A has a standard quota of 5.33. State B has a standard quota of 33.38. State C has a standard quota of 7.17. State D has a standard quota of 21.84, and State E has a standard quota of 16.89. Under Hamilton's method of apportionment, if there's an extra seat to be apportioned, which state would get the extra seat? Does anybody know how you, on Hamilton's method, determine who gets the extra seat if there's anything left over after you've determined?
Whichever has the highest decimal.
Right, exactly. See, you get your standard quota on Hamilton's method, and you chop off the decimal and you allot those items, and if there's anything else that needs to be allotted, you just look at who has the highest decimal. Well, who does on this problem?
E.
E, so E gets the extra seat. Okay. All right, does anybody have any questions on that problem? Okay. All right, let me test your understanding on this one. This one says, which paradox occurs when an increase in the total number of items to be apportioned results in the loss of an item for a group? Anybody know? There's the Alabama paradox, the population paradox, and the new states paradox.
Is it the Alabama one?
This is the Alabama one. The population paradox says that what can happen in the population paradox is that a group that increases their population at a lower percentage than another group gets more seats or gets an extra seat, and it causes the loss of it basically the extra seat goes to it changes the allotment such that whatever group it is that has the lower population percentage increase ends up being treated more favorably in a apportionment than another group that has a higher population increase. So that's the population paradox. What about the new states paradox? What does that say? Anybody know that one?
I can't remember off the top of my head.
The new states paradox says the addition of the new state or a new group causes the loss of an item for another group.
That's right, yeah.
So it'd be like if you had 5 groups that are getting apportioned items and you added another group, it causes, you would think that the group that it wouldn't change the allotment of the previous group that was already there when you add another group to it, but it ends up doing that in the new states paradox. So you just need to know on the population paradox, you just basically, everything's the same. You're using Hamilton's method to, because Hamilton's method produces paradoxes basically. And so the other 3 methods, Webster's, Jefferson's, and Adams' method, they don't produce paradoxes. They just don't satisfy the quota rule. What about this problem, Webster's method? A small country has decided to use Webster's method to apportion 63 seats according to their respective populations. The table shows the population of each state. Determine the number of states state E will get using Webster's method with a modified divisor of D equals 32,920. I'm going to let you try this one on your own, but before you do that, which way do we round on Webster's method?
Down.
Normal rounding.
Normal rounding, that's exactly right. Round normally. So let me let you try that. We're going to determine how many seats state E is going to get with that population and a modified divisor of 32,920. So let me see if you could try that on your own for about a minute. All right, so we've got 742,139. That's the population for state E, and we're going to divide by 32,920. So what do we get for that?
22.54.
22.54. Now, if we're rounding normally, we're going to either round up to 23 or down to 22. The question is, which way do we go? We're going to go up to 23. We're going to go up to 23 because if we're rounding normally, the 5 to the right of the, just to the right of the decimal rounds us up to 23. All right. Does anybody have any questions? Okay. Upper quotas. And I wanted to say something about the population paradox. You might get a problem like that on the, this is just from the previous problem, which was over here on the number 10. On that particular problem, you might see something where you have to calculate the percentage change for each group that is being allotted items. And so what ends up happening is if you have an original allotment of items being apportioned. Now, when there's a population change, you see that with the census, and you know, in our elections, we base it on the census, and that can change the allotment of seats in various elections. But if the group that has a lower population percentage increase than another group takes an item from that other group, that's a population paradox. So we don't have a problem on the review for that. I just wanted to emphasize that because you may get something like that on the test. It's, you know, we cover a lot of what's on the what could be on the test, but there's other things that you would have learned that are not on this practice test. So I'm just trying to emphasize those things as they go. So on this problem, we have a police department is apportioning officers to each precinct based on its number of crimes. The standard divisor is 16.8, and precinct D has 240 crimes. What is precinct D's upper quota? Now this is based, since we're dealing with a standard divisor, this is Hamilton's method, but you actually want to take the number of crimes, which is 240, and divide by the standard divisor. And so what do you get when you divide that? Anybody?
14.28.
14.28. Now the question is, what's the upper quota if you have a 14.28 standard quota? Now, you're in between, when you have a decimal on your standard quota, or even your modified quota, the upper quota is basically just rounding up. The lower quota is rounding down. So if we're the upper quota would be if we're going up to the next number, no matter what our decimal portion of the number is. So the decimal portion is 0.28. If we were rounding normally, we'd go down to 14. But this is asking what the precinct D's upper quota is, and it's just going to be 15. It's like rounding up no matter what is just what the upper quota is. So the upper quota would be 15, the lower quota would be 14 if the standard quota is 14.28. And that would be the case no matter what it is, if it's between 14 and 15. So
what method would it be if we were supposed to round normally?
That'd be Webster's method.
Okay, so it'll be like 14 if it was the X to round normally.
If it was rounding normally, it would be 14. Yeah, okay. But this is just asking what the upper quota is. So it's just more of you're not necessarily doing it to portion anything. It's just more of a trivial question. Just knowing what your upper quota is kind of what it's testing you on this. What would the upper quota be if you had 15.71?
16.
16, right. So that's all it's really testing here. But does anybody else have any questions? All right, let's try this problem. This says a group of consumers are asked to sample 3 sports drinks. You got A, B, and C, and rank them from favorite to least favorite. The rankings are summarized in the preference table. So you got this preference table. And we're just going to do this as we go. I'm not going to really give you time to do it on your own. We're just going to do it together. How many students voted in this survey? So let's add up all these numbers and determine how many of these how many voted in the survey on this one.
160.
160. And the second question says determine the winner by the plurality with elimination method. The way that works is you have to determine, because the plurality with elimination method is whichever candidate gets the majority of first place votes. Now, you have to know what a majority is. The plurality method is just who gets the most first place votes, but you don't necessarily have to have a majority. Plurality with elimination, you have to have a majority of first place votes. So what is a majority? It's basically greater than 50% of the vote. Any number greater than 50%. So what's 50% of the vote if you have 160 voters? That
80.
would be 80. So, but you can't win with 80. You got to have more than 50%. So what's the next number after 80?
81.
81. So 81 votes for a majority. So you have to determine what your threshold for a majority is. But determining the winner by the plurality with elimination method, you basically have to determine at the starting point, determine if any candidate has a majority. Well, A has the most first place votes. How many votes does A have? Or how many first place votes does A have?
73.
73. So A doesn't have a majority. So the question is, what do we do since we don't have any candidate with a majority? Well, what we do is we take the candidate with the fewest first place votes. So who has the fewest first place votes among all these candidates?
C.
C. So we get C out of there in the preference table. Just remove C. Move everybody else up one. So B is going to take C's place and take C's first place votes. Now it doesn't matter that C's out of there on any of the other voters, because it doesn't give any, C didn't have any first place votes on the other columns. So it won't affect, it will, but if we have to do it again, but we don't, because now how many first place votes does B have?
$87.
87. So now B won the election. So B wins the election in the plurality with elimination method. So because now B has the majority of first place votes, but we had to eliminate a candidate first to figure that out. And it's important to know who to eliminate, and you eliminate the candidate with the fewest first place votes if you have to. That's just if nobody has a majority, and you just do that until somebody gets a majority. So, all right, does anybody have any questions? Okay. Here's the majority criterion. This is going to be a theoretical question that says the preference table for an election is given using the board account method. C is declared the winner. Is the majority criterion satisfied? So explain your answer. Now, who wins by majority here? So the question is, we've got to determine who's going to win by the majority and to compare it with who won the board account method. Let me test your understanding here. What number of votes represents a majority on this problem? Anybody?
Are we going to like number it from like 3, 2, 1 or something like that? I forgot how it goes.
Well, you remember you figure out how many votes there are. So how many total votes are there?
It's 100.
100.
100, right? And then we divide that by 2 to get 50% of the vote. So that's 50. And so how many do you need for a majority?
51.
51, right. So now, who wins the majority by majority? Does anybody have a majority?
Oh, we were already given the board account. I'm thinking.
Right. Oh, you're thinking about the board account. Yeah, that is how you do the board account, but they already gave us who won the board account. Yeah. Yeah, we're determining the majority, who wins by majority. So who wins by majority?
Wouldn't it be G?
Well, it would be
C.
Well, B has 30. C has how many?
64.
Well, C it's
I don't know where I get 64 from.
Yeah. So, well, who has the most first place votes, and how many do they have? And do they win by a majority?
C has 55.
Yeah, C has 55. So C with 55 votes has a majority, and C also won the board account method. So is the majority criterion satisfied?
Yes.
Yes. What that says is if any candidate wins by majority, they should win by any other method. So, and C won by majority, and then C won by board account. So it's the majority criterion is satisfied. So does anybody have any questions on this problem? Okay. All right, let me let you try this one on your own. This one's one where let's see if you guys can determine the answer to this problem. This says there were 245 votes cast in an election. What is the minimum number of votes needed to win by a majority? So on this one, you guys need to try to determine how many votes the candidate would need to win by a majority. So let me give you about a minute on this problem, and then we'll go over it together. Okay, so we start out by taking the number of votes that are being cast, which is 245, and if we divide by 2, what do we get?
123.5.
So what do we need for a majority? Let me test your understanding here.
123.
123, right. You just go up to the, if you get a decimal, you just go up to the next number. Because 122 wouldn't be a majority, but 123 is greater than 50% of the vote. So it'd be 123 that you'd need for a majority. So does anybody have any questions on this problem? Okay. Let me let you try this problem on your own. This is Adam's method. This says the mathematics department has 30 teaching assistants to be divided among 3 courses according to their respective enrollments. The enrollments and the modified quotas are shown in the table. Use Adam's method to portion the teaching assistants. How many teaching assistants will liberal arts receive? So we're using a, well, actually they already give us the modified quota. We just have to determine, are we rounding up or down on Adam's method, or normally? Round up, that's right. So now liberal arts has a modified quota of 9.48. So what would it, how many teaching assistants would liberal arts get?
10.
10. So we'd go up to 10 on Adam's method. And you would round up everywhere no matter what the decimal is. So does anybody have any questions on this problem? Okay. One more problem. This is basically the board account. And so I want to give everybody a chance to try this on your own for maybe 2 or 3 minutes. The board account's the method of voting that takes probably the longest. Let me read through the problem here. It says a group of consumers are asked to sample 3 pizzas, A, B, and C, and rank them from favorite to least favorite. The rankings are summarized in the preference table. Which pizza won by the board account method? So you got this preference table here, and so we're going to determine the winner by the board account. So let me give you about 3 minutes on this problem, and then we'll go over it together. And this is the last problem in our review. So. Okay, so on the board count method, you determine how many candidates there are. So there's A, B, and C, and last place gets 1 point. So each you have the preference table, you have all these categories of voters that have certain preference tables, and the last place gets 1 point. Next to last place gets 2 points, and you keep going until you get to first place, which gets the highest number of points. In this case, third place gets 1 point, second place gets 2 points, first place gets 3 points. And so we basically just have to make a preference or make a table here. We got candidate A, candidate B, candidate C. And so for candidate A, candidate B, candidate C, you have to calculate the total number of points each candidate got. Well, let's start out with these 50 voters. Now in these 50 voters, so there's 50 voters right here. A got first place among these 50 voters, which means A, for all 50 of those votes, A gets 3 points. That's one multiplication. We need a parentheses around it because we're going to end up summing all this up. Plus, now when we go to the next column, 40 voters had that preference, and A was second place among those 40 voters, which means for those 40 voters, A gets 2 points each, plus 40 votes basically. But then the next column, there's 20. Apologize for these vertical lines here, but for these 20 votes, A got second place, which means for each of those 20 votes, A gets 2 points, plus these 30 ranked A last, third place, and A gets 1 point for those. When we multiply and add all this up, you get, because when you're doing this, you got to multiply everywhere first and then add. You get 300 for A. A got 300 points. Okay. Now let me test your understanding here. You got 50 votes here. How many points does B get for those 50?
3.
Well, B
1.
was 1, right? Because
okay.
B was third place there. Plus these 40, how many points does B get?
1.
1. Plus these 20, B gets
3.
3. Plus these 30, B gets
2.
2. So what do we get when we multiply all those and add them up? We get 210. So now we've got to calculate candidate C's points. For the 50 votes, C got 2, right? Plus these 40, C gets
3.
Plus these 20, C gets
1.
Plus these 30, C got
3.
And so now when we multiply everywhere and add these up, we get 330. So C got the most number of points. C wins the board account method. All right, does anybody have any questions on this problem? Well, that's pretty much all we've got. I'm going to send the recording to everybody, a link to the recording if you want to look this over again, or maybe didn't get a chance to write down certain things that you may have wanted to write down. So this, I'm going to go ahead and get this video set up to be sent out as a recording. And if anybody has any questions, please feel free to stick around and ask any questions. But otherwise, I hope you do well on the test, and I hope you have a wonderful day.
Thank you.
Thank you.